Welcome everyone to the Rancho Mirage Library and Observatory. My name is Eric McLaughlin, and I'm the astronomer for the Rancho Mirage Library Observatory. I'm being helped out tonight by our observatory coordinator, Lauren Zuckerberg. She's there in the chat. I'll be touching base with you guys, but we'll go ahead and jump in how we normally do here for this special Swoon at the Moon, and that is we're going to start with reviewing a few things. Hi everyone. Right here is a nice time-lapse view from the Goes West satellite of what was going on in our skies over the course of today. There's a lot of clear skies for us, thank goodness. Over the last couple months, we've had some interesting issues with regards to trying to do Swoon at the Moon, where we've been working through our waxing phases. So we had some issues with our waxing crescent and waxing gibbous. But tonight, we're doing a full moon viewing. And so to preface what to expect for a full moon viewing, we aren't going to be looking at shadow detail at all. Why? Well, because there aren't really any shadows going to be cast on the moon while we're looking at it here. And in fact, if we go long enough, we will be here right at the moment of full moon. The point at which the moon is completely full is when it's basically on the opposite side of our sky from the sun. So how does that end up looking? Well, let's go ahead and take a quick look at Stellarium to get a view of that. Here is Stellarium right now, and in Stellarium we can see where we're looking right now. Our small telescope is set up roughly from the perspective of this Stellarium view, which means we're looking right over the entrance to the observatory over here. And we can see a few nice and interesting things going on over here. Let's go ahead and put on our altitude azimuth grid, showing that we are not yet even looking 20 degrees up in the sky, which means we're looking down near the horizon. So we might expect a little bit of turbulence in the atmosphere. It's still pretty low, so we're looking through a lot of air. And we might also see a few other things along the way. But when we're looking at the moon here, if we are to compare its location in the sky with respect to the sun, we can actually turn off the ground here. And if we swing around a full 180 degrees, you'll see the sun is only just barely over 20 degrees below the horizon. So that is really the full comparison of where we're at. So around 22:22 or 10:22 local daylight time, that is when we expect the closest thing to being completely full for our moon. So, all right. So that's our general view here. The other things you might note in this view is we do have a couple of planets up, Saturn and Jupiter. We'll try and swing by them a little bit later to get some closer up views there. Now let me check a few things, make sure I'm not missing anything here. Ooh, happy birthday. All right. So let's see. All right, so here's where we're looking, of course, in the sky, but we can also actually zoom in on it, and the moon looks great here. But this isn't Stellarium's not going to show us a lot of detail on what's going on with the moon itself, which is why we have a great view from NASA's Science Visualization Service. They have a great page on lunar phases and libration, all sorts of fancy words, but what you end up with is a great diagram that looks like this. This diagram has a lot going on it, and to really discuss it in detail, what I'm going to do is actually make it a bit bigger. In the center, we have a wonderful map to actually show us a lot of different details here. We can actually note things like the Sea of Serenity, the Sea of Tranquility, and so on around. We can also note a few useful features, including this little graph that is hanging out directly behind the map. On one side, we have the Earth hanging out. Over here, you can see the Earth is on one end of this line. This line is a 2-scale graph showing the separation between the Earth and the moon. So Earth on one side, follow the line behind the moon over to this side, and we can see the moon is out near well over 31 times the diameter of the Earth away from the Earth. And its average is around 30, so it's further away than average, making it a little bit tiny bit smaller and a tiny bit dimmer in our sky. It's not really a big deal. You don't really notice it with the eye, but it is nevertheless nice to note. Here's some specific data on this exact picture, you'll note stuff like the timing for this. It shows 5 a.m. Universal Coordinated Time, so that is actually next hour. I pulled the picture from an hour in the future from when we're starting, so that way we're averaging close to that time. All sorts of other specific detail that is otherwise demonstrated nicely in this image, including this particular one here. This is showing the specific angle of the moon relative to a equatorial view of the from the Earth. You can see the moon is tilted pretty heavily over, and the yellow point on this picture is the substellar point, is the point directly beneath the sun. The blue point is the, well, sub-Earth point, you could say. It's the point that if you were standing at that point on the moon, the Earth would be directly overhead, exactly overhead at that point there. And let's see, I'll swing on up to this side. This is a great depiction of the current configuration of the Moon-Earth system in the context of the solar system. Why is it in context of the solar system? Well, because this funny ram's head here is actually referring to the point where the sun would be right at the vernal equinox here in the northern hemisphere. Thus, as we're heading into later this month, the autumnal equinox, you can actually see that the sun is currently over in this direction over here. By the autumnal equinox here in the northern hemisphere, the sun will be off in this direction here. So give it a few more days and that will shift slightly. You'll see the actual line of north and south will shift, and we can actually visualize this more as a movie if we so desire. It actually looks a bit like this. And this actually starts on January 1st, so you'll see the directionality of how the sunlight on the Earth falls. It starts down here by the vernal equinox here in the northern hemisphere. It'll be over here. By the summer solstice, it'll come down from there, and likewise over here. So all sorts of nice little things to spot on that. So that is what that particular diagram is showing us. All right. Just checking on comments, making sure I'm not missing anything. All right. Good to see you all here. Okay. So this is a great thing. We'll be able to use a lot of nice things with this set of information. And going on to note other things like whenever we're talking about the moon, it's worth knowing the scale. I always want to bring this particular image up when we're talking about the scale of the moon, because it's really useful to understand the size of things we're looking at. If you're anticipating seeing lunar landers here today, you shouldn't, because again, when we're looking at the full disk of the moon, we're looking at something like this. This shows the diameter of the moon projected onto the United States. And so if you're really expecting to see anything specific with regards to anything on the moon, it would be like trying to spot a tiny object like spot an RV somewhere in the US. It's incredibly hard, especially when you're 30 times the Earth's diameter away from the Earth. And so reverse it, we're 30 Earth diameters away from the moon. So yeah, it's going to be a bit difficult. To put that into other perspective, I can actually pull up NASA's Moon Trek, which this is a great feature. You can find this on NASA's websites. It's actually called Moon Trek. And with this setup here, we can actually take a look at those particular landing sites. And for example, let's go ahead and go and zoom in on the Apollo 12 landing site. If we do that, we will actually see an extra little detailed strip on their data here. But when we zoom in all the way in, you can really see that all the way up. I'm off. That's a crater. There it is. There is our lander right there. So with that view there of what we're talking about with respect to a view of the lunar lander, don't expect to see the flag because, again, our most zoomed in view will actually be something on about Let's go ahead and keep zooming out. Yeah, our most zoomed in view will be something about this scale. Maybe even a little bit bigger, maybe closer to this. So that is how zoomed in we're going to be. So don't expect to see any lunar landers. And again, because we're at full moon, all of the detail you see here, noting stuff like all of these little shiny edges on the craters and the nice shadows as well. Yeah, don't expect to see those either right now because we're at full moon. You don't normally want to spot all these details during full moon. What we look for during full moon is the actual color difference. And in particular, since there isn't that much color on the moon with how we're going to be viewing it, we're going to be mostly looking at the differences in bright and dark regions. There is one crater exception to all of the rules and detail. Often, Tycho crater you can actually spot really well when it's fully illuminated rather than when it is just partially illuminated because of the bright material that extends out from it. Tycho crater's down here. It's, let's see, it should be this one right here. We'll take a closer look at that one especially. Okay, we've looked at a lot of nice virtual views of the moon. They're all well and good, but let's actually go ahead and shift over to something a bit more real life. So we'll shift to our small telescope view right here on the deck, and this is it here. It's coming out a little reddish, and that is probably due to the camera settings. I wasn't able to actually fully get that going the way I wanted it to. Nevertheless, if we want to adjust things, we can actually adjust it like so. It's probably closer to real color at this point, but nevertheless, I'm actually going to leave it reddish for us. Just FYI, it doesn't look that red in the sky. It'll be a little bit of other hues. You probably could have heard that. That was quite a loud vehicle driving by. I apologize. Why the radial lines from the craters? Always a wonderful question there. Ron, let's go ahead and adjust our view. I mentioned we were going to be looking at Tycho crater, and you can see it in this view really dramatically. It is that bright spot all the way down here. This spot right here is Tycho crater, and it actually is a relatively young crater compared to a lot of the other ones here, and as such, when the impactor landed there, it actually spewed a lot of material out of it in a very dramatic fashion, and that material landed in those radial patterns going out from that point. And so, as it's all freshly dug up, it is not as darkened from being out in the sun for as long, and so it's nice and bright for that reason. My hair is actually just getting a little long, so it's all combed back, if that's the question there. All right. So, yeah, this is a great view and all. I do love our small telescope view because it gives us some really good context here. And with this setup, we can, again, spot some of those features on those maps. I mentioned the Sea of Serenity and Sea of Tranquility. Sea of Serenity is this one here, and the Sea of Tranquility is this one here. When we're talking about lunar landing sites, again, Apollo 11 was down here, Apollo 17 was up here, and we can even swap back and forth from here to our information slides. And actually, let me go ahead and pull our full big map up again. Oh yeah, that's right, it's here. Okay, there's our big map. So from this big map, we can start to spot some of the other landing sites. We, of course, have Apollo 11 and 17 marked, as well as 16 in this field of view, 15 up to the top there. And so we can actually get all 6 landing sites on our map right here. So how does that translate over to where we're looking over on our actual view of the moon? One of the things we can't normally do during our Swoon at the Moon nights is because we don't have a full moon, not all of the landing sites are completely illuminated. So if we're looking right here and we want to actually spot some of those landing sites, we can actually, again, go and mark some. We had Apollo 11 is roughly, let's see, Apollo 11 is roughly here. Apollo 17 is up in this region here. Apollo 15 is off. I got a rotated view here trying to make sure I match everything. Apollo 15 is off over in roughly this region right here. And we got Apollo 16 way down in the highlands. It's up in the highlands. These wider areas, the brighter areas, are the highlands, the actual higher terrain that is older than the darker terrain, which is the seas, the mares. They are actually areas that were lower lying and filled in with a lot of lava a long time ago. Now, let's see. So Apollo 16 was up in the highlands, roughly, if I got it right, roughly around here. And then Apollo 12 and 14 were off over on this side, off right around. Let's make sure I don't have my orientation all askew. Yeah, it should be on the order of right around here for 12, and 14 was off over here. So that would be marking all of the Apollo landing sites at this, well, all of the Apollo landing sites, period. Apollo 13, of course, did not land, so there is no spot to land for that. And there weren't anything after 17, and none before 11 landed. So that's all of them. All right, so this is a great view. I want to get a more magnified view, so we'll go ahead and switch over to our CDK 700 telescope like this. And right now it's looking off to the side just a bit. So let me go ahead and adjust this and get us back on target. See, there we are. Hopefully the controller connects effectively to the, oh, there it goes. Yeah, to the computer in there. We're quite a ways off, so we've got a number of quick adjustments we need to make here. All right, let's see. There we are. Okay, I think I know. Yep, that's where we are. Let's just adjust up here a bit. There's where I want to be. All right, now we are back at the Sea of Tranquility, and so I want to do just again a stop at a few of those lunar landing sites because they are worth noting with more detail. So Apollo 11, if we have everything oriented correctly and in a nice format, will have us being, yeah, so that's that. I got to get all my landmarks right. Apollo 11 landed right around here. So as I mentioned, we aren't all that zoomed in, so we won't be seeing any detail of those landing sites, but it's still worth getting a good view of them. Which zodiac sign would the moon be in September? Well, the thing about the moon is it actually moves very quickly through our sky. Over the course of 1 month, it makes a full revolution around the Earth, and it's a little bit shifted relative to the ecliptic, but it's still pretty close to it. But that means over the course of 1 month, the moon actually will pass through all 12 zodiacal constellations. As for right now, I can check Stellarium, see exactly where it is. The thing about the moon being big and bright is I am not able to just go and say, oh, it's behind those stars, because it's so bright it actually blots out those stars really effectively. All right, now I'm moving on up to the northern part of the Sea of Tranquility, because again, up here is where Apollo 17 landed. And getting my map up here, make sure I can actually spot it well. Yep, Apollo 17 would have been, I see those craters there, it would have been right about here. That would be where Apollo 17 landed. All right, let's see. Have they thought about sending a satellite to encircle the moon? Yes, actually. When it comes to, for at least communication, yeah, so there's actually a few things with regards to things going on at the moon. Back over in our information slide view, when we're looking at our moon trek view, those images that I was showing you of the lunar landers, those were not taken from the Earth. They were actually taken from satellites around the moon, including the Lunar Reconnaissance Orbiter. So, yeah, good question. Want to touch base on that. Is the moon about as reflective as asphalt? Yes, it is actually quite dark. If you want to get a good feel for how dark it is, it's maybe a little bit brighter than asphalt, but not much. It looks really bright just because of how much sunlight is falling on it. It's pretty darn close to asphalt, but it's actually a little more brownish in color. But yeah, that is a excellent question. All right. Let's see. So I want to go ahead and find some other nice detail here. I want to actually work my way down to Tycho Crater because it is a fun one. Again, I like seeing all those radiating lines coming out from it. Tycho Crater is about, it's on the order of around, if I remember correctly, 90 kilometers across. And I believe we're getting close to it. Oh, I'm going the wrong way, though. Starting to see some radiating lines. There it is. So yeah, Tycho Crater, when the sun is low on it, it doesn't stand out all that much, but when it is high in the sky, that big bright circle there near the center of the image, right there, that is Tycho Crater. With my terrible circle, don't worry about that. That is, again, a relatively young crater. It's still on the order of on quite a few millions of years old, so it's young as far as geological standards go. Let's see. Yeah. Yes, the medium dark gray. But yeah, when you actually look at it, it's a really interesting definition of gray, but it is nevertheless gray for most circumstances. Let's see, where's another good place to go to? I definitely want to spend a little more time in areas that are normally on the night side of the moon when we are having these events. Let's go ahead and head over to where the Apollo 12 and 14 landers were. They are up to the northwest of where we're looking right now, which means I need to aim the telescope more east because of the fact that we're looking at an object. Anyway, all these interesting things in perspective. I play it up for a good reason, because prior to ever conceiving of us actually setting foot on this object as though it was solid, it is the kind of place where, well, there's no reason not to think about it with regards to our local coordinates. And so when people looked at the moon prior to thinking about space travel, they would actually refer to the east limb or the west limb. And so while in our coordinates, what we're looking at now, I'm moving west on the moon, you would often refer to it as moving eastward when you're actually navigating. And why does that matter? Well, what's interesting is that nomenclature is not entirely gone. When it comes to things we can't land on, such as the sun or gas giants, often we actually still use that nomenclature. The east limb of the sun is, when you're looking at it, further west than the center of the sun. And when I say limb, I'm just referring to the edge as viewed. That is also a common nomenclature in astronomy. Let's see, where have I wandered off to? I've gotten lost on the moon. Okay, that might be a helpful spot there. Lost in the Sea of Storms. We're trying to get to the Sea of Storms here. Ah, that's a nice ridge there. That'll help us out. Am I all the way up there? Oh, duh. That's where I was. Okay. Yeah. I wanted to find this object here. We actually have a 3D print of this crater, and its name is actually escaping me. Let me check something real quick. there a Sea of Madness? I'd have to check that one. Oh, there's a number in here. Yes, there is a Mare Cognitum, which is basically the Sea of Knowledge. Let's see. I want do this button. Do. That's the one I'm looking at. Yeah, okay, it was. Duh. It is Copernicus crater that we're looking at right now. Like, I know it starts with a C, and I know it's not Columbia. No, it's Copernicus we're looking at. This guy right here. A nice big crater, actually somewhat similar in size to Tycho crater, and it might not shock you that Tycho and Copernicus would get craters that are roughly the same size and prominence on the moon. That is because Tycho was a great astronomer who took a lot of data, Tycho Brahe, and it was his data that Johannes Kepler, used to actually formulate the laws of planetary motion and mathematically show that it makes sense that the sun is at the center of the solar system, not the Earth. Likewise, Copernicus was one of the first to put forward a well-based theory for a heliocentric solar system. And so, yeah, the fact that there would be a Copernicus crater and a Tycho crater that are nice and prominent are really not surprising. The big difference between the two of them, though, is that Tycho is up in the highlands, while Copernicus is a crater down in the Ocean of Storms, as it's referred to, the Oceanus Procellarum. Don't expect me to pronounce any of those right. But right down south of Copernicus crater is actually where we have our Apollo 12 and 14 landing sites. If I can get some nice, useful reference on here, I might be able to tell it. Let's see. Who gets to name the seas? Well, those seas largely were named quite a while back. A number of them, I'd have to check the specific names of them. But today, when it comes to naming things, all of those things go through the International Astronomical Union, and it's a big bureaucratic nightmare, which is exactly what you want when you're trying to get the entire planet to agree on what something is named. Why does that matter? Well, because when it comes to naming certain things, like the planet Neptune, Neptune was discovered by William Herschel, who wanted to name it after Neptune or Uranus? It was Uranus. Excuse me, Uranus. Wanted to name it actually after King George. As you might imagine, no one but the British were on board with that. So yeah, it's actually a very good thing that we have a more well set up name for naming all these things. Are there small bright spots craters? Actually, a good number of them will be craters. Yes, that is where some nice material has been dug up from impact sites. Do they pick the landing sites for a particular reason? How close do they get? Yes, they actually picked all of the landing sites for very specific reasons. As this was a pathfinding mission, they increased in difficulty in a number of their landing sites. The Sea of Tranquility was nice and flat, and they thought that would be a great place to land for our first landing. And so Apollo 11 went to the Sea of Tranquility, not realizing that they'd be trying to land in a boulder field, so they actually had a bit of issue there. But each one stepped up in difficulty until you get to Apollo 15, which is starting to land in the highlands. But with Apollo 12, we are still down in one of the seas. Again, I was trying to get there. I'm trying to spot some nice bright spots to help me out here. I think I got a nice reference. Okay. Yeah. I'm looking at my map, and I see these three craters helping me point out that then Apollo 12's landing site would have been right about here. That would be where Apollo 12 landed, And then there was Apollo 13, and it was all sorts of a big problem. And so rather than going way into the highlands immediately, they actually stepped back some things and ended up having Apollo 14 actually land. If I have my area right, I want to say, yeah, Apollo 14 would have landed right over here. So yeah, it was much lower, much more... or rather, much less ambitious than it might have been had Apollo 13 succeeded on landing on the moon. So, that said, after Apollo 14, they took the lunar rover with them. The lunar rover there's only 3 lunar rovers on the moon. 15, 16, and 17 took them. And if we want to actually find 15, we need to go towards the northeast. There's a really great ridge right on the Mare Imbrium. And that ridge is where we find the landing site for Apollo 15. Let's see. Am I too far east? No, actually, we're right where we want to be. All right. This ridge passing right through our field of view here, this one here, that is a nice stretch of highlands. And so right near the edge of that ridge, right about here, is where Apollo 15 landed. And Apollo 15 was again the first mission to take a lunar rover, and they were able to cover a lot of distance because of that, including visiting a really great canyon that was likely a collapsed lava tube. How close do they get? Well, Apollo 12 and 14, as I was pointing out, sorry, I meant to mention this before I moved off of it. Yeah, that was about as close as that is the 2 closest geographically in landing, and it's still on the order of, hundreds of kilometers apart. Yeah, so this was Apollo 15's landing site, and then Apollo 16 was down south of Apollo 11, down in the highlands south of the Sea of Tranquility, which brings us full circle right back over to, let's see, right around here we got Apollo 11's landing site near the upper right hand side of the frame. The view I'm looking at is my map is a little bit washed out, so it's going to be hard for me to spot exactly where Apollo 16's landing site was. I already spotted or pointed out Apollo 17. So I want to make sure I get our last landing site here, just because it's great to be able to spot these. This is the first time we've ever been able to point out all of them during a swoon at the moon. So, where do they make the cheese? The cheese itself is made in a number of places. Yes, mostly. Well, just on Earth. Sorry, no moon cheese. It's not a real thing, sadly. I wish it was. Let's see if I'm looking correctly. Am I looking where I think I am? If I nudge to the right, do I see the Sea of Nectar, Mare Nectaris? Yes, that would be it on the right of the frame. So then what I'm looking at with that crater just on the right edge of our field of view, that one there, I'm trying to use as a reference. With that setup, that means our Apollo 16 landing site would be, let's see, can I spot it? Oh, that might be helping me. There's a crater down there. Yep, so Apollo 16, again, my map is a little washed out, making it very hard for me to spot this one, but I'm fairly certain Apollo 16 would be roughly in this area. That would be its landing site. So, again, can't show you anything more magnified than that, but that is roughly what we can get there. Yeah, thank you, Lauren, for noting the temperatures on the sunlit side of the moon. Yeah, it is a dramatic shift from sunlit side to the night side, the day and night side. It does shift dramatically, going from 120 degrees Celsius, well above boiling, all the way down to minus 30 Celsius. Yeah, that is a really dramatic shift, which is always worth understanding. It might be really hot out in the day there, but it's still not going to feel the same way to what we feel here because there's no air on the moon. you're really dealing only with temperatures that are coming from radiation and contact. Those are two of the three ways in which heat is conducted: through conduction, actually touching something; through radiation, actual light transmitting the energy and causing something to heat up; and then convection is the main other way. And that's the convection we really notice a lot when we walk outside this time of year, because while we might notice the radiation if we're in the sun, the convection of all of the hot and slightly more humid air, the higher water content of the air, is really what we notice a lot there because of all the relative rates of heat transfer for us. Anyway, it's a wonderful question. Yes. Yeah, Ron is noting one area that is much cooler. Ron, by the way, is one of our docents. Thank you for being here, Ron. That minus 430C, it is going to be in like Shackleton crater at the South Pole, where it is permanently in darkness, and so yeah, it just is always cold. Its thermodynamic equilibrium keeps it quite a bit cooler for that reason. So yeah, we visited a number of really nice sites here, but I want to see a few other things. We can actually visualize these things in another way using a nice tool called SpaceEngine. And SpaceEngine is great because we can actually view things not just from here, we can actually visualize them from there. So with this setup, we can actually take a look at the moon and go ahead and fly off to it, leaving the valley behind here. As we fly off to the moon, you'll notice it takes quite a bit of time because the moon is, again, a long way off. It is on the order of around, on average, 380,000 kilometers away. So I want to make sure I don't crash into the moon. I will note, whenever you have an inept person using intergalactic transportation here, you might have some probability for flashing. So a little bit of a seizure warning in case I crash into the moon here. All right, so back at the moon here, I always love to point out Apollo 15's landing site. So let's see if we can't actually fly down to it. If I have my lunar geography well set up, we should be able to spot, yeah, there's that nice lava tube there. You can actually spot, I'll go ahead and pause it here so I can point it out, that nice lava tube going right up here. It's actually a nice canyon now because it did collapse long ago. And that little canyon has a nice lunar lander right near it. And I believe it's even highlighted in SpaceEngine for us. I think we're heading straight towards it. That little dot there should be it. SpaceEngine, though, doesn't show things necessarily as they are now. When we get there, it'll actually show us a nice little lunar lander with the ascent module still attached. The ascent module is the section that the astronauts actually used to leave the surface of the moon. There it is. And so this model includes that. It's not there anymore. The only thing left there is actually the gold section you see at the bottom of that there. All right, so yeah, so this is a great little mock-up of Apollo 15's lander. And yeah, this is roughly what their terrain looked like at their landing site. They had quite the spectacular set of views with all these hills. Compare this to where Apollo 11 landed, and well, it's even flatter than it looks looking in this direction here at Apollo 11's landing site. It was very flat there because, again, the seas are areas where you actually had a lot of magma fill in those low-lying areas, and so it ended up relatively flat because of that. So just a quick note here, always fun to make a nice virtual visit to a couple of these landing sites. Now, again, the highlands are nothing like those lowlands in a lot of ways, and they're thus much more challenging. And so, yeah, that was the way they decided those landing sites. They actually went ahead and ramped up the difficulty the entire time they were actually doing all that. All right, so got a good question of what the other side of the moon looks like. Now, we're actually at a point which happens once a month where the dark side of the moon actually coincides with the far side of the moon. because it's entirely illuminated on the Earth-facing side, the night side of the moon is actually the far side of the moon. The moon actually orbits at the Earth at the same rate at which it rotates, so one side of the moon is always facing the Earth. So, whoops. Get the moon locked on target. There we are. So let's see. I am all sorts of flipped over, but we're not that far off. So how does the near side of the moon compare to the far side? Well, let's go ahead and fly around to the other side and find out. Again, the far side is currently in darkness because, well, that's what happens when we're looking at the moon at full moon. So let me go ahead and do this button. I want to rotate with object, and we'll go ahead and advance time on into the future and watch as the far side of the moon's phases change. There we go. So if you were in a point where they're actually, again, going back to a question earlier regarding to the idea of communications, there's actually a Chinese satellite positioned probably a bit further back from where we are with this particular view, but it is set up to actually aid in communicating with a lander on the far side of the moon. Now, as the far side of the moon has come into a good amount of light, now you can really see the difference compared to the near side of the moon. And that is a almost complete lack of seas. It's almost all highlands, save for one nice little spot up on over here. And the funny thing about the names on the far side of the moon is because, well, the first people to really get a good view of the far side of the moon was, in fact, the Soviets, and so there are a lot of Russian names back there. So if we pull up some of those names, for example, that sea is Mare Moskovinci. So it's the Sea of Moscow is that sea over there, basically. So yeah, there's a lot of Russian names on the far side of the moon there. There's another nice bright crater named Jackson. Let's see. Do we have details? It's actually a Scottish astronomer they named it after. So let's see if we can't spot that here. Yep, we can actually spot pretty well. Jackson crater named after a Scottish astronomer. Let's see. I want to... Oh, dear. We are all kinds of broken with how we want to be moving here. That correct it? There we go. Okay, so yeah, Jackson crater. It's another one like Tycho. It'll be a younger one, but with all of these radiating lines of material spewed from it going out from here, this is another example of what happens when you actually have a good impactor that kicks up a bunch of dirt. So that is Jackson crater. But yeah, excellent question about the far side of the moon. No King George crater back there. That's a good point. Yeah. No, given the British weren't the first to look back there, probably not. But yeah, the King George, by the way, being referenced there, same one that was on the opposite side of the war that President George Washington was fighting in. So yeah, that same George. So yeah, we don't have a planet named after the people we fought the Revolutionary War against. So it's good. You can see Americans weren't exactly on board with naming it George either, despite, President George Washington. Anyway. Yes, the Chang'e rover is over here. I'm not exactly sure where over here. I'd have to check that. But let's actually see if I can't find that out really quickly, because I want to know. Oh, that's the wrong Chang'e rover. That's the one on the near side. Wrong rover. Let's see if I can't find that one. Give me a moment. I just need to know the coordinates, then we might be able to get an idea of it. I think it's Chang'e 4 is the one that actually landed on the far side. And pardon my pronunciation. I know very few words in Chinese, and I'm pretty sure I pronounce all of them terribly. not helpful. Yeah, for Chang'e 4, that is the one that has the communication satellite hanging out off the far side of the moon to help actually get that communication with the lander there. Landing site is within a crater called Von Karman. Alright, should be able to find Von Karman. Let's hope I spelled that right. Spelled it right. Didn't come up. Ah, the south. Oh, it's in the South Pole. Aitken Basin. Okay, let's see. Make sure I can find this one here. Is that where we're looking? I apologize. It takes me a little bit of effort to find things on the distant side of the moon. It's a bit of an effort. Okay. Yeah, it was worth a shot. I'm not sure I'm going to be able to find it as easily as I'd like. Mm-hmm. 44 degrees south, 175.9 degrees east. All right. That should help me out a lot. Okay, that's close enough. Was the satellite in place before the Chinese lander arrived? Yeah, it would have needed to be in order to actually transmit telemetry from the far side, so I'm fairly certain they got that in place beforehand. Okay, now I think I can find it. All right, let's see if I can find it well enough. Switch over to this view here. Okay, let's see. We need to go south, quite a bit south. And with this south setup here... Oops. Oh dear. What have I done? There we go. Too many windows. All of the different windows here. Right. Not too lost here. Okay, there we go. All right, so Chang'e 4 will have landed on the order of, let's see. Yeah, in, where's my marker? In this area here. Now, okay, where is this area? We've moved around all sorts of weirdly. I've totally lost track of where we are. Well, let's go ahead and turn ourselves on a nice geographical grid for marking here. There we go. Now we can get some nice reference. It is quite a ways south, but on that far side there. So, again, we're looking roughly... make sure I didn't lose it. Oh, dear. Lost track of where it was. Oh, yeah, there it is. Okay, sorry. In this area, down... This area, down here, this area. There we go. Why did a... No, there we go. Now it's a circle-ish. Yeah, if you want to call that a circle. Anyway, yeah, that's roughly the area we were looking at there. Back over in SpaceEngine, if we're comparing that to where we were looking before, yeah, that's all far side of the moon. We were looking over on this side. That is now night in this particular view. In any case, that's all well and good, but let's go ahead and switch back over to looking at some other interesting things. I mentioned earlier that there were more things in the sky. I love talking about the moon, mind you. It is a wonderful object, but there are more things to see in our sky right now. And among them include things like Saturn and Jupiter. So why don't we go ahead and actually swing on over to those guys. It'll take a few minutes to get there. I want to actually point out those moons and actually a few other things. So while I get the telescopes moving over to those objects, or to Jupiter, let's go ahead and give me just a second to do that. Now, I will note, as we are dealing with a number of things going on in our atmosphere, don't expect like Hubble Space Telescope views of these planets here. We can only do so much to actually make these happen. So please be lenient on us, on your expectations. Let's see. I had one of my computer connections close out, so give me a second to reestablish that and control it in a good way here. Okay, we want to go to Jupiter first. It's a great big planet, biggest planet in the solar system, and most massive, of course. All right, its current azimuth is 190, so we'll go ahead and head over to that at an altitude of 32 degrees above the horizon. There we go. So let's go ahead and tell this to get over to that. And you'll see the big telescope just below me is moving right now. I'll let the dome figure itself out in getting over there because I want to get the small telescope over there so we can get our live view of the moon set up. So give me just a moment. Okay. Apologize for the noise. All right, so I should have our small telescope on target. Yeah, there it is. All right, so we'll switch over to our small telescope view here. And we got a nice little tiny looking Jupiter there. I'm actually going to increase our exposure time a lot because this is our lunar exposure time. We need a lot higher exposure time to spot. Well, you don't need that much higher to spot detail on Jupiter, but I want to spot the moons with this view, which means we really need to crank up our exposure time, and we'll even increase the gain. It won't look all that great, but we will spot those moons as it gets a bit glary there. Never mind that green pixel. That is just a hot pixel there. It looks like we may have lost a little on our focus looking at those. But let's see what we can do with this. All right, I'm going to go ahead and crop this in a bit to give us a view there. Let's see, we want roughly the same shape as our window. There we go. And it's a little small, make it bigger. There we go. Yeah, we definitely have a little bit of a focus adjustment we need now that things have cooled off a little and the optics of the telescope are dealing with the heat a little differently. So I'm going to reach over here and try and adjust this. There we go. That's a little bit better focus. All right. May not be perfect, but given the way it's moving right now and the effort it would take for me to get the Batinov mask for focusing, that's about where we're going to leave it right now. All right. So in comparison to our nice information view, our stellarium view here, you can see that Ganymede is the one by itself with Io, Europa, and Callisto on the other side. All right, so back over here. Again, we have in order actually going out in terms of the size of their orbits. Io is the one that is in closest to Jupiter, with Europa being next, and Ganymede being third, and Callisto being the furthest one out. They all have really dramatically different orbit times. Io in on the order of around 2 days, with Callisto taking 16 days to go all the way around. And what does it look like if you actually want to spot all of those orbits? Well, we can actually highlight it over on this view here by hitting this button. Yep. Yeah, if I actually click off of it, you see all of them. There you go. And the funny thing is Jupiter doesn't have dramatic seasons, so we are always looking pretty close towards the equator of Jupiter, and as such, we're also looking very near the plane of all the orbits of Jupiter's 4 largest moons. These moons are referred to as the Galilean moons because they were discovered by Galileo, and as such, they are nice and bright, but they also move basically just side to side relative to Jupiter, which was really useful for Galileo. It's a little bit confusing at first because they just appear in different places from night to night. For example, if we actually were to observe this from night to night at this same time, we can actually just see that how those moons move. It's really dramatic. They shift all over the place, and I'm losing Jupiter here. Get back there. And so those positions move quite dramatically, but if you actually plot all of those points with careful measurements repeatedly, you can actually figure out which moon is which after the fact. I know this because there's a great classic astronomy lab that we have students do where they simulate those observations and actually thereby calculate the periodicity and the size of the orbits of each of those moons, and thereby actually calculate the mass of Jupiter. Because going back to Johannes Kepler, who I mentioned formulated the laws of planetary motion, he also, by doing that, made a way to weigh planets and stars. And it wasn't until Isaac Newton reformulated that actually by watching the dynamics of two objects orbiting around each other, you can actually figure out the mass of an object. And so that's through Kepler's third law, Isaac Newton's derivation of it. But yeah. All right. So with that said, looking at what we've got here, I want to go back, of course, to our nice small telescope view where we are actually viewing those moons. And I will leave it here while I get the big telescope into its position, because it is a challenge to get that one that is much more magnified on target. Ooh, actually, we aren't that far off. Okay, so we'll just switch right on over to our main telescope view, our CDK 700 view, and you'll be like, why are we looking at a blank screen? Well, I can see where Jupiter is. It's hanging off just on the edge of our field of view, and there it is. Pull that down into our field of view here. All right, and so with that there, let's go ahead and adjust our exposure time and make that a little bit more visible for us. There we go. That's looking pretty good. And we'll go ahead and crop our field of view here to roughly this. And boop. It's nice and cute, but let's make it bigger. So again, blurry is to be expected. What you do if you want to get a good clear view is, as you'll notice, this is a video, and what you do is you would take a long video, and with that video then you would compile them all into a nice clearer image. We can do a little bit of that, but it's probably not going to even be all that noticeable because, as you can see, Jupiter's kind of dancing around there, and so each frame has a different level of distortion to it, and if you include those frames in your stack, the really distorted ones, you're going to end up with an increasingly just blurred image. Nevertheless, we can still see a lot of detail in individual frames here. Let's see how it goes if I actually do some live image stacking here. I'm going to do an average of 5 frames, see if that gets us anything nice. Do a few more than 5. Do 13. See if that clears out any of that, or if it just makes it still blurry. Yeah, it's still blurry. Yeah, there's a few things you can do to actually make these things turn out better. Our skies aren't the clearest at the moment. They're nice and transparent, mind you, but given the heat we have in the valley, we have a lot of different layers of temperature we're going through, and we're still not all that high up off the horizon. If you might recall back on our information slide, you can actually see we are only about 32 degrees up from the horizon, which is still pretty low on the horizon. So back to our big telescope view. This is a great shot of Jupiter where you can see the zones and the belts. The zones and the belts are those different stripes you see there. These zones will be the lighter colored regions, and the belts are the darker colored ones. These ones here. Now, trying to spot. Yeah, I don't really see it. I don't think we won red spot roulette. Looking at it, I would expect to see the great red spot with this level of clarity. This is actually quite clear for what you can expect to see just through a live video. All right. So before we get moving on to one more planet, there's a question. Oh yeah, we will be going to Saturn next. But yeah, before we do, any questions on Jupiter? Because I know I didn't actually talk all that much in detail about it. Now, Jupiter is, again, the largest and most massive planet in the solar system. It's actually more massive than all of the other planets combined, and that alone is something that is impressive. However, it is worth noting that it still is a tiny fraction of the overall mass of the material in the solar system. The sun contains well over 99% of all of the mass in the solar system, so this might be This might be the largest and most massive planet in the solar system, but it's tiny in comparison to the sun. And if you want to see our images of the sun, go ahead and check out our Systems Are Go videos after this. We are now publishing those time lapses of the sun that we get there. But yeah, after we're done here, hang out here. Any reason for the 2 main stripes? There's a lot of unknowns when it comes to what's going on inside Jupiter, but really when we're looking at things with regards to Jupiter, what you will notice is the directionality of things, the prevailing winds in those regions, and we can actually see something similar happening on Earth. That is, and I might have them backwards, but the direction of, the flow of material in one of these belts might be this way, and then the zones around it would be moving more this way. And that is a common thing you see in atmospheres, is actually this type of stripe pattern forming. We see it here on the Earth. It is a part of the reason why you find deserts all at around 30 degrees north and south latitude. It's the reason why there is a dramatic trade wind over in around where you'll find Hawaii, and why you have incredibly high winds at the 40-degree latitude mark. In the south especially, where there aren't many continents to stop things, you have the roaring 40s down there, and you actually get this pattern largely through patterns of convection and other things going on in that. I unfortunately am not a meteorologist, so I can't really explain it all that well, but it is related to something we see in convection cycles, because there will be areas where that air is rising up and settling down, and it helps cause that differential, or rather different directions in prevailing winds. Is the red spot shrinking? Yes, it is. It actually has been shrinking noticeably over the last at least 30 years. Back when the Voyager spacecraft went past Jupiter, it was on the order of around 3 to 4 times the size of the Earth, the diameter of the Earth, I should say, and it is now closer to being about 1.5 times the size of, or the diameter of the Earth, and it could eventually go away. It is a wonderful thing to spot, but it is nevertheless a storm that is driven by all sorts of things, and those things can shift over time. That spot has been around for at least 150 years, possibly been around since around the time of Galileo, but we lost sight of it for a while, so we don't know if we just were really bad at spotting it, or if it was actually gone for a while. So if it does disappear, well, maybe it'll come back again later. So, any recommendations for good stargazing binoculars? There are a number of good places to start, depending on your level of interest. If you have a set of binoculars, start using them. That is really the first bit of advice I would give, is just start using them and use them with a nice little guide. Again, at the library, we have a wonderful guide that is stargazing, or it's a sky map for small telescopes and binoculars. It is phenomenal for just starting to find things and utilize those things. Once you actually get familiar with any binoculars you might have, and you might be at that point, person asking that question, Steve, but if you're at that point, I do really like the Celestron binoculars, the big aperture binoculars you can get, and if you want to really fork out a huge sum of money on the order of thousands of dollars, there are some $4,000 ones you can get. I'm trying to remember the name of the company. It's not a name you hear frequently because they are that high end on their optics. It starts with a V. It's a Japanese company. I unfortunately can't remember their name. I'm sorry. But for most practical purposes, Celestron's binoculars and Orion's binoculars will be pretty decent. I use some quite old Celestron binoculars that I actually inherited from my grandfather. They're really nice, but yeah. Let's see. Wind of what kind? So the wind on Jupiter is pretty dramatic, actually. On the order of laughing at the wind speeds we encounter on the Earth, on like hundreds and hundreds of kilometers per hour, like 250 kilometers per hour, I think is pretty frequently common, and that's outside the storms there. In the Great Red Spot, they're even higher. All right, I love this view here, but I definitely want to swing over to Saturn, and so let's do the same procedure we did before. Let's go ahead and see what it looks like virtually, see what we can expect there, and then go on after that. So zooming out from Jupiter, Saturn is not far off, and it's important to note what we're looking at here, with Jupiter being to the right of Saturn, to the west of Saturn in our sky. That tells us something, because we're looking out at the plane of the ecliptic here. And in fact, I can highlight the exact location of the ecliptic with one of these buttons. Too many buttons. That was not the button I wanted. Whoops. There's the ecliptic. So yeah, it's a little bit, hang on. Adjusted some things. It's a little bit off from the ecliptic, but the ecliptic is the path that the sun takes in our sky, not all of the planets. And as you can see, they're close to that. The red line is the orbit of Jupiter, and the red line now is the orbit of Saturn. Which direction are they moving in their orbit? Well, they're actually moving off in this direction here, and that direction there. And so you might wonder, who's catching up to who? Well, Saturn is nearly twice as far from the sun as Jupiter is, and so Jupiter takes about 12 years to orbit around the sun, while Saturn takes around 29. And so over time, Jupiter will overtake Saturn. So over the course of the next months, this distance between these two planets, will be decreasing over time until we get around to our winter solstice. Again, we're about at the autumnal equinox coming up later this month on September 22nd, I believe. And by December 21st, they will actually be as close as they will possibly be. There is a good opportunity to catch both of them in one telescope there. Highly recommend trying it out for it. But it will be something you have to spot in the very early evening because they will be setting early then. Anyway, back to Saturn though. Let's go ahead and zoom on into Saturn. Now, Saturn has seasons that are about as extreme as the Earth's. Its axial tilt is not really minimal. It's on the order of the same as the Earth's. That's a little bit different, but yeah, emergency swoon for that one. We'll see what we do around that time. We've got a few plans for there. But as Saturn has significant seasons, we aren't looking at the orbit of Saturn's moons all in one plane. In fact, if we actually do this, you can actually see all of those orbits highlighted really nicely. And I'm not going to go into huge details on a lot of these because I'm actually working on a nice virtual tour for some of these moons. But the main ones you can spot here are, of course, Rhea, Enceladus, Tethys, and Titan out here. Iapetus is way out there as well. That's a really interesting multicolored moon. Titan, of course, is really interesting. When we're looking in the telescopes, we might be able to spot Titan. It'll be really hard to potentially get the others, Dione as well. They are substantially dimmer than Jupiter's moons, being that they are much further away and substantially smaller. Titan is the second largest moon in the solar system, second only to Ganymede back over at Jupiter, but as it is twice as far away from the sun, it is substantially dimmer. So, with that said, let's go ahead and actually start getting some things moved over there. And while I do that, I'm not going to leave you with just a virtual view. I want you to keep looking at something while I shift these telescopes. So here's one last view of Jupiter. Oops. Sorry for kicking the desk. All right, so let's see. How is Saturn looking? We'll go ahead and swap over to our small telescope view. It's hanging out in the field of view there. Let's see, hang on a second. Do this real quick. This button. This is the full unmagnified view. And let's go ahead and adjust. Oops. Wrong. Telescope adjusted. Guess it's a good thing we got somewhere here. All right, so if I brought the exposure down, you'll be able to see a nice clear view of Saturn. But before I do, I want to try and spot moons. So let's go ahead and increase that gain up to an absurd amount. Now, one other thing you'll note here is a big difference in scale. Where we were looking at Jupiter, the field of view was largely filled with those moons. Not the same with Saturn. Again, we've got some really high gain here, and so it's really popcorny, but nevertheless, I want to zoom in a bit in roughly this region here. About there. Should be pretty good. And make it bigger. All right. So you can spot some moons here. And again, when we're looking at this, we can see Titan is actually hanging out right up here. That is that big, large moon. And then we had, I believe it was Rhea over here. Tethys over here and Dione down here. We even have Iapetus hanging out all the way over here, which is really cool. Iapetus is a moon you only spot on one side. You only spot it on this side because it's actually two-tone. One side is very dark, one side is very light. The leading side of Iapetus is the dark side, and the trailing side is the light side. So as Iapetus is moving this direction in its orbit, we're looking at the trailing side of it right now. And when it's on the other side, it actually becomes substantially harder to spot, to the extent that when it was first discovered, it actually was only discovered on one side. They could not spot it on the other side. And why is that important? Well, and I want to make sure I get the astronomer right. It is either Huygens or Cassini who discovered it. Lauren, if you could check on that for me, that would be really helpful. The thing about Iapetus being spotted only on one side, the astronomer who discovered it correctly surmised that it was actually due to two different colors on the surface, that one side was a dramatically different color than the other. It took getting spacecraft out there, the Cassini spacecraft, to actually get that information and show that that was the case. So, and let's see, I want to make sure, did I actually label all of them right? Let's see, there's our view there. Yeah, Rhea on the right, Tethys on the left, Dione on the bottom. Okay, back over here. So that's all well and good. And I can just decrease the exposure time here, but I want to actually do that mostly with our main telescope. So give me a moment while I actually take our main telescope over to Saturn. You'll see the telescope moving right now just beneath me. And the dome will move in just a moment as well. Goes. All right, now I just need to actually pull the planet into view. Let's see. Getting that main telescope on target right now is a little bit of a challenge. It needs to have its pointing reset, so it's having a little bit of a time landing on objects. Not far off, but it's near. Ah. Getting there. Oh, shoot. Just went right past it. There it is. Oh dear. Okay. If it settles on target, that looks good. Okay. Oh, well, no wonder I was having extra trouble getting there. Oh, and it's 22:22, which means it is precisely the moment of full moon. So, as much as I want to swing telescopes back over there to give you that view of precisely full moon, it would take a lot of effort, and we would lose sight of Saturn and such. And, okay, so, yeah, here's the small telescope view. The big telescope I currently have nice and blown out too. So here's that view there, a bit zoomed in as well. You can see a few other moons in this view. You can actually see Enceladus, which is really neat. Enceladus hanging out right there near the moons. Let's see. Swinging back over to that stellarium view, I just want to see. All right, so Enceladus is just above Mimas. We can spot Mimas. I love that because Mimas is my favorite. Yeah, Mimas is hanging out just under Enceladus, right there. Mimas is my favorite place in the solar system. It has a spectacular view of the rings. Highly recommended vacation destination. I've not managed to get there, but if you can, let me know. I'd go with you. Anyway, with this overexposed view, that's all well and good. Let's go ahead and turn that gain way down because we love seeing the moons, but we want to see rings right now because this ain't no flying saucer. This is a wonderful planet here. There we go. Get that nice and well exposed. And we're going to, let's see, that's actually a longer exposure time than I want to do, but we'll go ahead and increase the gain a bit. There we go. Doing about 1 second exposures right now. Let's go ahead and get ourselves a nice magnified view. Cut out a lot of those pixels and just stick with the ones that have a planet in it. Boom. There we go. All right. This is a great view of Saturn right now. And as you can see, we're actually off at an angle a little bit to how the sunlight is falling on Saturn. So you can actually see a little bit of a nice shading going on up in this section of it here. But there's another really great thing to spot, and that is this little black gap here. That is the Cassini division, discovered by Giovanni Cassini. And the reason that exists is because of Mimas, that little moon that was hanging out roughly like right over here. And that has to do with something called orbital resonance. It orbits around Saturn twice as fast, or sorry, twice as slow as any particles in the Cassini division. Anything hanging out in that area or that area, it will orbit twice for every orbit of Mimas. What does that mean? Well, that means it'll go around once and pass by Mimas and get tugged by it ever so slightly. Then the next time it is in that same spot, Mimas is on the opposite side, and it's not doing that much to tug on it because it's on the opposite side of Saturn. Then its next time doing a full orbit, Mimas is back in the same spot it started in, so it has a constructive building effect that pulls those particles out of that little section of the rings, creating the Cassini division. At least that's the main idea on what's going on there right now. But yes, I love Mimas. It's a wonderful little moon. But yeah, let's see. I believe we had a question of, are the rings shrinking? Yes, they are actually shrinking. They are expected to be around for on the order of around 100 or 200,000 years, roughly on the hundreds of thousands of years time frame. And that is telling because it is a very wonderful thing that we happen to be able to spot these rings. They are very tenuous, and as we are looking at them at an angle, they are right over the equator of Saturn, and we see them at that angle because, again, Saturn has seasons, and right now we're actually looking at its northern summer. This hemisphere is experiencing summer, heading towards fall just as we are, but it takes a number of Earth years for it to go through its seasons. As it takes 29 Earth years to go all the way around, it will take a quarter of that per season. And again, the northern hemisphere has the reverse seasons from the southern hemisphere. Anyway. Yes, and one of the important things to note about Saturn, as it is the second most massive planet, it is actually, and it's also the second largest, it's actually much closer in size than it is in mass to Jupiter. It's about 9 times the Earth's diameter, whereas Jupiter is around 11 times the Earth's diameter. But again, Jupiter is more massive than all of the other planets combined, so that means that Saturn actually has dramatically lower density than Jupiter. In fact, it is the least dense planet in the solar system. It's actually less dense than water, and that means that if you could, you can't, but if you could actually take Saturn and put it into a giant bathtub of water, it would actually float. You have to be careful, though, because when you drain out all the water afterwards, it might leave behind a ring. And that's one of those stock bad jokes for you. So if you had a nice groan, good job. That is what it's intended for, to make sure you're paying attention. Yes, so this is a wonderful view of Saturn here, and we're probably going to wrap things up here soon. Do you guys have any questions at all on what we're looking at now or have looked at throughout our night here? I'm actually going to try and get some more of those moons back while I wait to see if you have any more questions. We'll increase the gain here. Blind ourselves with Saturn here because I want to spot some moons. Right? Yeah, we can spot a couple here. Yeah, we're off on that side, so let's see. I'm going to hit... Where's the button I want? That button. Freaks out for a second, but we're back. Okay. I want to just nudge this just a bit over to the right. I want to see Enceladus and Mimas. Enceladus is a wonderful place. It is, again, this little fuzzy dot here. While Mimas was hanging out right down here. Let's see if we can't try and get that any more clearly visible. Just crank that gain up to absurd levels. Okay, that's a little too absurd. Take that back down there. Getting washed out by just the light from Saturn. I don't think I'm going to be able to pull it out quite the way I want it to. With that, I'm probably going to need to use a little bit of an adjustment on the gamma. Let's try pulling that up. Oops, wrong way. I want to do the gamma the other way. Might turn down the gain to see what we can do with that. Level of gamma. With the right setup, gamma can pull out more of those subtle, darker features. I don't know how much we're going to get out of this. Anyway. Alright, well that's about where the best I'm going to be able to do with trying to get Mimas back out of there. So I'm not going to bother with any more of that. Oh dear. Not what I want you to be doing. Excuse me. Alright. Anyway, got a good view of Saturn to wrap things up on. So I want to give a very special thank you to the Rancho Mirage Library and Observatory Foundation. It is through that foundation that we're actually able to offer events like these. It's also a wonderful wonderful group. And so if you're interested in the foundation, I believe we've got a link in the description. If not, Lauren can drop one in the chat there. Likewise, we have a lot of different programs. I mentioned a number of different videos along the way. I'm working on a nice virtual tour of the moons of this planet here, as well as that planet itself. So hopefully that'll be coming out in a couple of weeks when I actually get it all done. But all that said, we have a lot of different videos as well, so you can check those out at our YouTube page and a number of other things at the Rancho Mirage Library website. So thank you for being here. I hope you guys have a wonderful rest of your night. Remember that the sky waits for no one, and so you should really go out and keep on looking up. Good night, everyone.